All right, thank you so much for having me. So we have this amazing slide here. How would you like 2 extra hours every week? So my talk is all about saving time, automating things, so you can spend time on things you care most about. So today I'm basically going to talk about 3 key issues we as mobile developers face and how you can solve that using Fastlane. And in general, I want this whole talk to be very, very practice-oriented, that you can go home today and can already start using something and learn something new. So some of these quotes we know as iOS developers. Like, we cannot release an app update right now because Chris is currently on vacation. The provisioning profile doesn't contain all the devices we need, so we have to like resign everything. We cannot release an update right now because our build is broken. The marketing team asks you for the latest screenshots for the website or for the newsletter. And the best one, oh, that's just such a small bug fix. No user will notice it anyway. It will just wait for the next release. So these are all things we've probably heard in the past, but these are not things we want to hear, right? We wanna fix that. And that's basically where Fastlane comes into play. First off, I want to talk about how does your release day look like. It's an exciting day. All your hard work finally pays off. It gets out to the user. But there is like so many steps involved. You do some testing, automated testing, manual testing. You generate new screenshots. For example, if you change the design of your application, if there's a new device, and so on. You have to build your application, which is simple enough as long as you don't run into code signing issues. Finally, you generate a push certificate if you support push notifications. Upload the application, wait for processing to be finished. That's a new step I added there. And then submit your app for review. And the problem is that this easily takes up the whole day. And this is all time you as an iOS developer or Android developer have to invest. And again, you want to spend time on something you really care about, building a cool product. So that's why I set out to build Fastlane, which is a set of open source command line tools that help you automate all these tedious tasks like testing, building, signing, and deploying your application. And Fastlane itself consists out of 9 separate smaller tools that each solve one very specific task. Things like testing, maintaining provisioning profile, and building, deploying your application. And Fastlane itself on top is the thing that connects all these tools and third-party tools into one workflow. All these tools, again, are open source. They are all command line tools and all available on GitHub. So what are the goals when we talk about things like continuous delivery? First off, it should be automatic. We just want to be able to push one button, and it should do everything for us. Secondly, we want to store as much information as possible in version control. This is really important. All the build scripts, all the build information should be in version control, in Git, for example. This way you have a proper history. This way you have everything you need in version control. That means you check out the repo, and you can immediately start building and deploying your application. Next up, developer independent. When Chris is on vacation, we still want to be able to deploy our application. So everybody, even like new employees who are on the first day at the job, should be able to build your application. And we don't want to have things like internal wikis where we have documents describing how to do that, right? Again, we are developers. We want to have it in version control. So I don't want to go into detail to all of these tools and all the things you can do, but instead focus on like the 3 most common issues you've probably experienced in the past. First off, a major pain point, screenshots. Our favorite topic, code signing and provisioning profiles for iOS. And then automating your deployment pipeline. So every time you publish a new application to the App Store, both iOS and Android, you have to generate new screenshots. Every time there's a new device size, every time you change the design of your application, every time you add a new language. And it's really hard to do screenshots right. Just to give you an idea, on iOS, if you have 5 screenshots for 6 device types, for 10 different languages, you end up with 300 screenshots you have to first generate locally and then upload to iTunes Connect. So there's one tool called Snapshot that helps you like automate the whole process for you. It uses UI testing, which was recently introduced by Apple at last year's WWDC, and you basically tell Snapshot how to navigate in your app and where to take the screenshots. And it would then iterate through all the languages and device types and generate the screenshots and collect them for you. And then finally, you can upload them straight to iTunes Connect using another tool called Deliver. And of course, there's the same thing for Android. It's called Screen Grab. and it works the same way. It just uses espresso tests. And you can upload all the screenshots straight to Google Play using a new tool called Supply. So how does this all look in action? So if you have Snapshot already set up, all you have to do is enter Snapshot in the command line. It would then detect your project settings and start running UI tests. And you can already see the simulator jumping up here. And this all runs in the background, which means you can do something else while your Mac generates the screenshots for you. This is extremely useful. And once everything is done, it will collect all these screenshots into a folder and can then straight be uploaded to iTunes Connect. And one really nice thing is, after it is finished, it generates a nice HTML-based summary of all the screenshots of all the devices in all languages. So you get a great overview of how your app looks on all these screens. And a lot of companies use this actually to just be sure that your app looks okay on all the screens. In particular, if you support German, the cancel button, abbrechen, takes up like half the space, half the screen. Okay, now to our favorite iOS-specific topic, code signing and provisioning profiles. So for all the iOS developers here, raise your hand. Who of you saw this dialog here before? Oh, that's literally a whole room. That's a good sign. Okay, so this is, while this dialog sometimes helps, it might also break stuff. So it's a little dangerous. So I want to talk with you about how code signing works and how to do it right. Because many people don't really understand it, of that whole concept of code signing. And just a very basic overview is, first off, you need a code signing identity. A code signing identity is basically your certificate and your private key. And you can use a tool called cert to generate one. This private key is only stored on your local machine. It is not on the Apple developer portal. That's the reason why you have to manually transfer to a new Mac when you transfer your code signing identities. Next up, SCI. As the name tells, it deals with provisioning profiles. And provisioning profiles are the connection between your code signing identity and your app identifier. Provisioning profiles are stored on the Apple developer portal and can always be received from there. Again, the only thing that is only on the local machine is the private key of your certificate. Finally, you would go ahead and build and sign your application. You can use a tool like Gym, which is one of the Fastlane tools to do that. And looking at this graph, it is extremely important that the certificate and the provisioning profile match each other. Otherwise, you will get a cryptic error message at this point now when you actually try to code sign. And finally, you end up with a signed IP file ready to be uploaded to whatever service you're using. So looking at this, you can just run these 3 commands. And of course, there are more parameters available, but usually the default values are pretty okay. But these 3 commands still look like a lot of work. So we're going to go into detail of how we can automate that. Yeah, it's far too much. So, but before we do that, about code signing, Apple recommends that when we do code signing, that each developer in the team has its own code signing identity, which means that you have one app ID for every app you have. You have one code signing identity for every engineer in your team, and then you have one provisioning profile for each app ID and for each developer. And additionally, for each environment, ad hoc, development, app store. Which means if you have a few developers and a few apps, you end up with hundreds of provisioning profiles, and your developer portal looks something like this. And it's basically, you end up with a big mess. And you have to think about things like, how does onboarding for a new user, for a new engineer look like? How does his first day of work look like? And this solution is not ideal. And I was thinking about a different approach. What about instead of having so many different code signing identities, you share one code signing identity, which you use to deploy your app to the App Store. You can store this code signing identity and its private key in a Git repo, because you already use Git to sync your source code. So you have a separate Git repo with your code signing identity in it. Additionally, you can also encrypt it to just having a secure Git repo. And this way you can just onboard a new user. Very simple. And we actually implemented this concept with a new tool called Match. And just to give you an idea how it looks like, you first just run Match init, and it will ask you for a URL to a Git repo. The nice thing about Git repos is that you have a very fine access control. you can define which user has read access or write access. Next up, first time you want to run it, you just run match app store to generate a new app store provisioning profile and certificate. And that was it. That was the whole thing. And you run this on every machine where you want to be able to code sign your application. The really nice thing about this is that you don't have to give access to the developer portal to your engineers, which means not everybody in the team must have access to the developer portal. They just need access to the Git repo. So I would really recommend checking this out. It's on codesigning.guide. You can find more information how to use that. Next up, automating your deployment. So think about the following situation. Your boss asks you for the latest beta version to show to your clients. And you would then go ahead and do all these things. You increment the version number. You commit and push the version bump. You make sure you have a valid provisioning profile with all the devices. You would then build and export the binary, upload it to some beta testing service, add release notes, and finally distribute it. It's a ton of work. So that's where Fastlane comes into play. So we can reduce all that to just the push of a button. First off, Fastlane uses a so-called fast file, which contains all information to deploy your application. And it's basically you define which steps to run, in what order, and Fastlane will make sure to execute them. If one of the steps fails, the whole lane will fail and it will stop running. So how does the configuration file look like for the example we were just talking before? First off, we define a lane, in this case, a beta lane. That's the first line. Then we increment the version number, we commit the version bump, and push it to our Git remote. Next up, we're going to use cert, sci, and chim, or we could use match at this point. And we know this combination. That's a combination to build and sign our application. And finally, we upload our APA file to a Crashlytics beta, for example, or Hockey, and then post a message to Slack that the build is ready. So the nice thing about Fastlane is that it comes with so many built-in integrations. So currently there are over 160 integrations, like HipChat, Slack, Hockey, Crashlytics, email actions, Git actions, and so on. And a nice thing is if an action is not available yet, you can easily extend Fastlane to use your existing shell script, your existing Ruby script, or you can just build your own actions. So looking at the whole file now, how does the Crashlytics action know where it can find the IPA file? Or how does chim know what provisioning profile to use? So these are all things Fastlane takes care of you. It will pass on information from one build step to the next one, so you don't have to think about it actively. So once you've finished writing this file, how can you run it? Easy enough, Fastlane beta. How does it look like in action? This is a release to test flight, and it is using the iTunes transporter to upload the binary. iTunes transporter is something that is bundled with an Xcode. And it's done. Looking at the output, you sometimes get these nice little tables of summary. That means you will always see of the parameters that were being used at this point. This is extremely useful if you go back in history on your CI system and you can immediately see what was being used. Next up, it will always show you the commands that were being executed. Also a very important point, so you can easily debug if something doesn't work. So one thing I want to talk in particular about is Spaceship. So many of the tools of Fastlane communicate with Apple in some way. And how does it work? There's no official API, right? There is a tool called Spaceship, which is part of Fastlane. It's its own Ruby gem. And it takes care of communicating with Apple. It accesses 3 different API endpoints: iTunes Connect, the Apple Developer Portal, and the API that Xcode uses. And it provides one unified API for these 3 different hosts using a Ruby library. How does this look like? How would you use that? So first off, you would call spaceship.login and provide your username. On the first time running it, you will be asked for the password. And then you can do things like fetch the certificates or find an application. Then you can access metadata of information of your application. You can modify your app locally, and then you can push the changes back to the backend. It's similar to core data or active records, but you're modifying developer resources, which is really interesting. So by doing so, you can build your own tools without having to actually do all the work around accessing the API. So to make it easy to play around with it, and you can start using that today, there is Spaceship Playground. So after installing Spaceship, you just run Spaceship in the command line. It would pull up this information sheet that shows you how to use Spaceship. And you can just type things. Like as you can see, all apps equals tunes application.all, which means all iTunes Connect applications. And then you get a list of all the applications with the information. So yeah, I can really recommend using Spaceship to build your own tools and just play around with it. One thing that was recently released was something around simplification files. So some of you, especially if you use bitcode, probably have had the problem if you use a third-party crash reporter that Apple recompiles your application on the backend. They recompile your application after it got approved, which means that your third-party crash reporters don't show the stack trace properly. So if you ran into that, you can use Fastlane to fix that. You can run this periodically and basically just download the latest simplification files from Apple and upload it straight to things like Crashlytics or Hockey. So that is all the code, and you can find more information in the Fastlane docs. To show you another thing about what you can do with Spaceship, I want to tell you a little bit about boarding. So Spaceship is a Ruby library, and it's a plain HTTP client, which means there is no web scripting or clicking involved. It's just plain HTTPS requests, which means it's really fast and has a high test coverage of 98%. And that also means that it runs on Linux as well. That means it runs on the server. So with boarding, you can basically set up a landing page for users who want to beta test your application using TestFlight. You don't have to manually go to iTunes Connect and add them as testers anymore. And this can be deployed using the one-click Heroku deploy button, which is really, really cool. And it's just basically a project to demonstrate what you can do with Spaceship. And this was something I built over a weekend. Next up, something which is not a Fastlane product, but a third-party service I want to talk about. It's Appetize. Appetize allows you to stream your iOS and Android applications in your browser. You upload a .app or .apk file, and it will spawn simulators somewhere in the cloud and allow you to stream it right in your browser. The initial goal from the web service was to be able to put that on your marketing website. So if you want to sell your application, you would basically say, hey, before you buy it, you can try it out in your browser with limited functionality. So I was thinking about what can I do with that? How can I build something on top of that? So I didn't come up with something. So let's talk about another tool that helped me. And Ash mentioned it this morning. It's called Danger. And I worked together with Otto on it. And it's already production ready. You can start using it already. And we use it fast as well. It's extremely useful. It allows you to define rules for pull requests. Things like that your pull request body must contain a link to a Trello card, for example. Or that some files in your Git repo are protected. They should only be modified by owners of the repo. Or you want to show the test results in line in GitHub. This is extremely useful. When people submitted pull requests, the build was failing, but many of the users didn't actually open up the build log. So now it is posted straight to GitHub as a comment. So that is Danger. And combining Danger with Appetize was a really interesting thing I did a few weeks ago. Think about the process when you submit a PR of an iOS app where you say you add a new button to your application. You would submit a PR, describe what you have changed, and currently most of the time you would maybe attach a screenshot so that everybody knows how it looks like. But to try it out when you review the PR, you do all these steps manually. You would clone the report and check out the branch with the new feature. You would then build and install it on a simulator, and then navigate inside the application, which might take a while, to finally see the new button. Combining Danger with Appetize, I built Device Grid. And basically, when you submit a pull request, after like a few minutes, it would go ahead, add a comment as a bot, and it would show you all the languages you support, all the devices you support, and you can now click on iPhone 5s, and it will stream your application with the new button right in your browser. So this is extremely useful. It is not launched yet. It will be launched probably this week, but it's already on GitHub as one of the open pull requests. So just to give you an overview of how the process looks like, this is you as a developer typing code. You submit a pull request on GitHub, which triggers Danger on your CI system. Danger then uses Fastlane to build your application and upload it straight to Appetize. Appetize then offers a stream in the browser, which another developer can now use to stream your application. That is basically the circle that happens every time you submit a pull request. And I think this is super fascinating. And I was also thinking about extending that to not only offer streams, but also to just trigger a snapshot and generate screenshots and post them right to GitHub, so you don't even have to click on a stream anymore. So that was the introduction to Fastlane and how it will save you time, like every single day. And again, Fastlane supports all kinds of setups, no matter what tools you're already using. In particular, it's very extensible. You can add your own tools. And you can find more information on how to get started on fastlane.tools. Thank you.
It was a great presentation. Have you thought about making these tools not only for mobile platforms, but using this in more general manner?
That's a very good question. So a lot of developers actually use it to deploy their CocoaPods, which is kind of related. And another thing is that Fastlane is deployed using Fastlane itself, which is very interesting. It's actually a very complex deployment script of like 30 different actions, but it shows that by adding your own custom actions, you can use it for anything.
Yeah. I was thinking about maybe some deployments of the front end or back end servers, like not particularly in the context of mobile apps.
Right. Yeah, it works. I don't see a big reason why you would do it though, since the power of Fastlane is basically that you have all these built-in actions and you can just start using them from day one, and they're highly optimized for mobile. So if you have like your backend or front-end deployment script, there are already existing solutions out there. So I don't see a big reason why you would use it, but of course you can use it for that, yes.
Okay, great. Do you have any questions?
Hi, thank you for the nice talk. I have a question about integration with CI systems. Because you showed us a script that basically signs and builds the app. Where does the CI come in this setup?
Basically, one of the slides I described that you want to store everything in version control, right? You have all the deployment scripts, all the certificates, everything you need in version control, which means all you have to do if you want to run Fastlane is run Fastlane and the name of the lane. It doesn't matter if it's on your machine. It doesn't matter if it's on your CI system. It's always the same thing, which means it doesn't matter if you use Travis, Circle, Jenkins, whatever. You just add one build step, which is Fastlane lane. That's all.
Git pull, and Fastlane, and the name of the lane.
Yeah, and the thing is that it will also generate JUnit reports. So things like Circle and Jenkins, they will pass those, and then you see like what step took how long and what step fails. So it actually integrated, but you don't have to do anything. You just get that for free.
Great.
Hello, thank you. What's the best solution to manage multiple teams? For example, I'm a developer. I have multiple teams. Should I use Spaceship or whatever?
You're talking about you as a developer work for multiple companies, multiple teams?
Yes.
Okay. There is not much you have to do extra. Basically, for each of your projects you work on, you have a Fastlane configuration. So additionally to the fast file, you also have an app file, which basically contains the team ID and the app identifier. So if you run, for example, match in this one project, it will automatically know what team it is in and what application it should run for. You don't have to think about that. So basically, you just navigate in your terminal to the project you want to work on, and it just works.
Great. And sorry, another question. What about you said integration with TestFlight for beta, and what about Fabric.io with beta?
Of course, that works as well. Yeah.
Oh.
So there is integrations. I don't even know all of them. So for TestFlight, there is its own tool called Pilot. The reason for that is because it also allows you to manage testers, like add new testers, remove testers, upload builds, and so on. And there is integrations for Hockey, for Crashlytics Beta, that's the Fabric thing, and for like all the other commons one as well. I think there are like 6, 7 different beta services supported.
I got a similar question to the previous one because we got one app that uses a few teams, one for enterprise deployment and one for public deployment. And what will be the best way to manage it?
So the way that works, usually if you have enterprise, you have a different app identifier, since it's unique, right, across the whole Apple system. So the way it works is that inside your app file that contains the app identifier, you can define different app identifiers for different lanes. And you can look into the docs folder. There is the advanced docs. You will find it there. And basically, you just define, I want this to be my app identifier, except for these lanes. There I want to be a different app identifier. And there you would specify the enterprise app identifier.
Thank you.
Hi, Felix. Thank you for work. Fastlane is better tool. I have a question about Snapshot. Snapshot command. Snapshot is great tool, but he use with default Xcode UI test. It's problem. For example, my app will be change state on the screen. Will be upload all network data, and I run snapshot. Snapshot run earlier or later, and I don't know when will be run snapshot.
What do you mean if it runs before or after? Or what is the question?
On the screen,
Yeah.
Will be load data.
Okay.
And after tab button, I will be snapshot command. Snapshot default screen run. And I don't know snapshot tool will be run after load data. Later load data.
So what I always recommend is when you run snapshot is to fake all data. Basically, all network requests should be stopped. The reason for that is you want to be your screenshots to be like really nice looking. So you want to be sure the content is right. And let's assume you have something like a social network. The content will always be different. And you don't want the random content to be on the screenshots. So I recommend for that reason to have fixed like data, like stop data. And this way, you don't have the problem of like latency and being offline and all these things. And you can do all that using UI tests, basically.